We can apply calculus to parameterized curves just as we can apply it to curves defined by functions of y in terms of x. To see how, let's start with this curve, parameterized by x of t and y of t. And let's pick 2 points on the curve. If we want the slope of the secant line connecting them, then we find the change in y and the change in x. Their ratio is the slope of the secant line. Note that we need to indicate a direction for the changes in x and y since either or both could be negative. In this case, the change in y is negative, so that line's arrow points down. What we really want isn't delta y over delta x, but dy over dx, so we'll take a limit. The slope of the tangent line at t is this limit as delta t goes to 0. Note that delta t is hidden in delta y and delta x because both depend on t. We can divide both the top and the bottom by delta t and then apply the limit law for quotients to get this. But this is just dy dt over dx dt. In other words, the slope of the tangent line is the ratio of the derivatives of the components defining the parameterization of the curve. We're assuming that x of t and y of t are both differentiable, or at least they're differentiable at the value of t that produces the point in the xy plane at which we want to find the tangent line. We're also assuming that dx dt isn't 0 at that value of t, otherwise we couldn't apply the limit law for quotients. As an example, consider the curve parameterized by t cubed minus t and sine of t. The slope of the tangent line of this curve when t equals 5 is cosine of 5 over 3 times 5 squared minus 1. Let's finish by talking about an application. Going back to the curve from the beginning, suppose that this curve is the path of a moving object. Since the path isn't a line, a force must be acting on the object as it moves. Let's pick a point on the curve and draw a tangent line there. If we suppose that the object is traveling along the path, but at that point all forces acting on it stop doing so, then the object will continue moving on a straight path. That path is the tangent line.